Welcome, my name is Connor McKenzie, and I am going to be doing some videos on various subjects, mostly math or science related, and anything else that I think might be of value to me, or anyone else actually, kind of think of it. Anyway, today I'm going to do some videos about balancing equations, or more specifically, my way of balancing equations. Now, if you've balanced equations before, then good, because I can't really teach you how to balance equations. Well, I could, I just don't want to right now. So this video is specifically on the algebraic approach to balancing equations. Let's pick a good color. Jeez, why is this hard? Okay, so let's say I start with, let's say I start with some amount of, let me just check that's registering. Yes, okay. Some amount of hydrogens, and is that registered? Yes. And plus some amount of O2 equals some amount of H2O. This is a very simple balancing equations example, so you could probably figure it out on your own. But for my purposes, we're going to do it the algebraic way. So first of all, this should be produces, not equals. Okay. Produces some amount of H2 plus some amount of O2 equals some amount produces, some amount of H2O. So what numbers go in the blanks? Well, we don't know what numbers, so they could be pretty much any numbers, but we're going to call them variables for now. Get on to the math side of it immediately. Okay, so this is term A, or number A. I'm going to call this one B, and this one C. So now, what do we have here? Well, we have one term that produces hydrogen and nothing but hydrogen. It's also the only thing that produces hydrogen on this side. We also have one term producing hydrogen on this side. It's the only term on the side, so obviously it's the only term producing hydrogen on that side too. So if these two are the only things that produce hydrogen, then the amounts of hydrogen that they produce must be equal, because that's what balancing equations is all about, having equal numbers on one side and on the other. So what does that mean? That means that however many hydrogens this produces must be equal to how many hydrogens this produces. So for every 2 hydrogens this term produces, this term will produce 2 hydrogens. So that means for every 1 coefficient here, this will produce 2 hydrogens. So for every 2 hydrogens that this term produces, this C term will also produce 2 hydrogens. I don't know if you can see that very well. Okay, yeah. So if you're wondering, I'm using Microsoft LifeCam and just video recording it on a webcam and a laptop and a couple stacks of books with a shoebox on top. Odd setup, I know, but it works. Or at least it does the job, I think. So, now, this is our first equation, and the equation is for hydrogen. So let me do that in a better color. This equation is for hydrogen. Now, we can make another equation here for oxygen, because the number of oxygens on this side here, also have to be the same as the number of oxygens on this side here. So, if, by the same logic reasoning, this term produces 2, and this term produces 1, invisible subscript there. So, let's make an equation for every 2, so the B coefficient creates 2 oxygens, and the C coefficient creates 1, or I could just write that as C. So what this is saying is this coefficient here, B, times 2 is equal to C, which makes sense. Like if you have 2 oxygens and you have a coefficient of X, if this term creates only 1 oxygen, you're going to have twice as many of them. So 2B equals C. So So now we have our two equations, and this is a system of equations. System of equations. And we can solve this mathematically. Let me just check that I'm not making any errors, okay? So we can solve this mathematically. This first part here can be reduced to A equals C, and then the other equation here just stays the same. Now let's solve, the next step is to solve, actually the next step is to create an equation where all the terms on the left side of the original, chemical equation are on one side, and all the terms on the other side of the original chemical equation are on the other side. So what we have to do is we have to add, some of the variables and subtract variables, multiply, divide, etc., until we get something in the form of XA plus YB equals ZC, and X, Y, Z are just the coefficients, where the A, B, C are the actual terms. So, I know that was probably a bit confusing, but actually scratch that. That's way too confusing. Anyway, so we want to get the A's and B's over on the left side, and we want to have both A's and B's in the equation, and we want to get C's on the right side. Well, C's are already on the right side, so all we need to do is get A's and B's in the same equation on one side. Well, let's take this 2b equals C equation. Let me circle that better. 2b equals C. Let's put that down here. And let's add an A to both sides, because we need A in the equation. C plus A. Now we have 2b plus A on this side of the equation, but now we have an A on this side. So in this case, now we need to substitute using this equation. So if A equals C, then we can substitute the A in for C, and then we get 2b plus A equals 2C. Now, this actually, can I think of it? Hold on. Okay, so if we have 2b plus A, now this has an imaginary invisible coefficient of 1. Now if we just put these three values in for their corresponding coefficients, then we'd get a 2 here, a 1 here, a 2 here, and a 2 here. Okay, for 1, the hydrogens don't match up, and 2, the oxygens don't match up. So that obviously doesn't work. Okay, scratch all of that. All the way back to here. So, okay, the next step is to solve both of these equations for a single variable, and we have them both solved here for C. So that's good. So let's solve them both for C. So we've got them solved both for C. I'm just going to write them again. A equals C, 2b equals C. Now remember, what this equation was telling us in the original thing was that for every of this term produced 2 oxygen, and every of this term produced 1 oxygen. Imaginary 1 there. So, if this B term produces 2 oxygen, and this C term produces 1 oxygen, then if we just put this in for B and this imaginary 1 in for C, then we'd get 2 times 2 equals 1, which obviously is not true. So what we need to do is we need to take the reciprocal of both coefficients. And if you took the reciprocal of 1, that's 1 over 1, which is just 1. So c stays the same. And now b, you have 1 over 2b equals c. Well, we can't exactly have half a term. That's like splitting an atom in half. Unless you had nuclear physics, you can't do that, and we're not there yet. So for these purposes in this level, you have to get them all to whole numbers. So how do we get this to a whole number? Or, sorry, to an equation that's written in only whole numbers? Well, if we have 1/2 of something, then to get it to a whole number, we need to multiply it by 2. So we multiply both sides by 2, and then we get, change color again, these 2's cancel out, and we're left with b equals 2c. Then if we do the same for this side, a to the power of negative 1, a to the power of negative 1, plus 1 c to the power of negative 1. And then, well, I think I said that wrong, but anyway, since there's one coefficient on both terms, the coefficients wouldn't change, so we'd still be left with our original equation of, oh, that's the wrong color, sorry, of a equals c. Now, we want to solve both sides for a single variable, or single multiple of a variable, and we've solved here for 2c, so we have to solve here for 2c. So what we need to do, we need to multiply by 2 on both sides. So now our equation is 2a equals 2c. And now you have a 1b there, a 2c there, and a 2a there. So if you put these coefficients in for their corresponding coefficients in the original equation, this is the original equation in case you've forgotten, because I know this is a long video, then we'll get, let me just rewrite the equation, something h2 plus something o2 produces some amount of h2o. And if we put the numbers in, for example, we had 2a, so let's put 2 in for a, and we have 1 for b, so let's put a 1 there, and we have a 2 for c, so let's put a 2 there. We have 2 times 2, which is 4 hydrogens, and on this side, and we have 2 times 2, which is 4 hydrogens on this side. On this side, we have 1 times 2, which is 2 oxygens, and oxygens, I'm going to use my O's with, O is this, 0 is this, just for future reference, or like that. That's a 0 for future reference. So that's an O. So we have 2 O's on this side, and then we have 2 times 1, 2 times 1 O's on this side, so we have 2 O's on this side. So the whole equation balances out.